You've likely made this sound to scold a pet. Or maybe you've used this one to imitate a trotting horse. In Western languages, these are isolated noises, but in the Khoisan and Guni language families of Southern Africa and several languages in East Africa, they are functional lexical consonants used to distinguish words. The sounds we make in English use only the front of the tongue. They lack a posterior release at the back of the mouth, which means they cannot connect to a vowel to form a spoken syllable. A true lexical click is a dual closure obstruent. Producing one requires coordination between two independent parts of the tongue operating at the same time. To understand how these sounds work, we have to look at a system that bypasses the lungs entirely. Almost every consonant globally is powered by a pulmonic egressive airstream, air pushed outward by the lungs. Click consonants rely on a lingual ingressive mechanism. The power source is the tongue itself, drawing air inward. This requires building a sealed, airtight pocket inside the oral cavity. This enclosed pocket is defined by two boundaries. An anterior closure is made by the lips or the tip of the tongue. Simultaneously, a posterior closure is formed by pressing the root of the tongue against the soft palate or uvula. In this configuration, the mouth acts as a pneumatic pump, generating acoustic pressure independently of the respiratory system. This is the four-step sequence to generate that pressure. Step 1. The tongue rises to establish front and back closures, isolating an air pocket. Step 2. While both anchors hold firm, the tongue's center drops. Expanding the volume of a sealed space causes internal air pressure to drop. Through this rarefaction, the tongue creates a vacuum. Step 3. The forward anchor releases. High-pressure external air rushes inward, creating a sharp pop. Step 4. The rear anchor drops. This reconnects the mouth to the throat and lungs, allowing the transition into a vowel. The click we hear is the result of this choreographed biomechanical sequence. Linguists call that forward vacuum break the influx. The International Phonetic Alphabet provides 5 dedicated base letters to map these release points. This is a map of those placements. The bilabial click is produced by compressing the lips. The dental click is formed by pulling the tongue blade from the upper teeth to create a high-pitched release. The lateral click is formed by releasing air over the sides of the tongue, specifically around the molars along the alveolar ridge. The alveolar click occurs when the tip of the tongue is pulled downward from the postalveolar roof, generating a hollow, low-pitched sound. Finally, the palatal click is made by snapping the flat blade of the tongue backward from the hard palate to create a high-frequency crack. However, these 5 symbols only document where the vacuum breaks. They do not describe how the sound integrates with the vocal tract's overall airflow. The limitation of using only the base symbol is that it ignores the simultaneous, independent action of the rear closure. That secondary action, controlled by the vocal cords and the back of the tongue, is called the efflux. This determines the phonation of the consonant. This is the phonetic formula for a click. The forward articulation plus the rear articulation equals the full consonant. Pairing a palatal influx with a voiceless velar efflux at the back creates a tied symbol for the complete consonant. By keeping the same palatal release but voicing the rear closure, you create a different phoneme. Routing the air through the nasal passages creates a nasalized click. By uncoupling the front and back of the tongue, languages transform a few placements into a combinatorial phonetic matrix. Because the tongue is maintaining 2 closures at once, there are physical limits on which sounds can follow. Linguists call this the back vowel constraint, a phenomenon found in languages like Khoikhoi. For years, it was assumed these rear closures anchored at the velum. Ultrasound imaging of the living human tongue root proved that for some clicks, the anchor is actually much deeper. This schematic of a palatal click shows a flat, forward tongue posture. When plotting an E sound, it aligns closely, making the transition efficient. Conversely, the alveolar click's tongue root plunges backward, anchoring against the uvula to create the vacuum. Transitioning from this retracted root to the forward position of a high front vowel adds a 50 millisecond physical delay. This delay makes it biomechanically difficult for these syllables to occur. This means the mechanical effort required for certain clicks determines which vowels can feasibly follow them in a given syllable. This biomechanical tracking reveals how a language's total sound inventory is built from the independent movement of the tongue. The Ta language of Southern Africa uses these independent movements to a high degree of complexity. Ta speakers layer these sequences, transitioning a click to an ejective, a voiceless fricative, or a breathy voiced nasal, all within a single segment. This matrix shows the sound inventory of Ta. By leveraging these mechanics, the language utilizes 115 distinct click phonemes. These sounds represent the limit of independent coordination between the front and back of the vocal tract, utilizing the full mechanical potential of the oral cavity.